S. Chan presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Now, how we can see the back surface of the mirrors? In order to see the back surfaces of the mirrors, that means when some portion of the light that is get refracted or the transmitted, what will happen to the light? So that can be understood in terms of laws of refraction or the laws of transmission. So these laws are given by the Snells. So we will understand the properties of the refraction of the waves.
If you want to study this topic in detail, refer to the book by S. Chan Publishing. Link is provided in the description box.
Myself, Dr. Narinder Kaur. Welcome to S. Chan Academy. So now what are the laws of reflection over here? Refraction. Now what is refraction? Refraction is a bending of wave when it passes from one media to the another media. That means the light has to pass from one media to another media. So what does that mean? Now, if we are separating by the mirror two medias, here is a one medium, so that is a first portion over here and that is a second portion. Now, in the first topic we understand, so there is a normal with the surface, means now when the light is incident over here, if this is incident at an angle theta I, and if this is a mirror which is separating to the two media, what is the condition behind that? The surface of the mirrors from both sides, it is not properly polished. That means they must be semi-polished so that some portion of the light that can be reflected and some portion of the light that can be refracted. If one surface is fully polished, so in that case, either the light is properly reflected or the properly refracted. So in order to for the light to get some portion of the light to get reflected and some portion of the light to get refracted, the mirror surface that must be semi-polished. So that means from both ends, from the front and back, the mirror surface that must be semi-polished. So that is the main property, main requirement over here. Now when the light is incident over it, now some portion of the light that will be get reflected, theta r with the normal, some portion of light that will be get refracted. That is the angle of reflection, that can be represented by the value r over here. So these are the requirement over here. So refraction, that is a bending of wave when it passes from one media to another media. So that means now this wave that will get bent along the normal. That means now the density of the medium, if this is D1 and that medium density is D2. Now what will happen if D1 is more than D2? That means the density of the first media is higher than density of the another media. Then what will happen here? So in the first case, when the D1 is more than D2, means if the light is incident over here, so in this case, if this is a normal to the surface, when the density D1 is more than D2, light, it diverted away from the normal, means it will diverted away from the normal. So this angle is R and that angle is theta I. So it will refracted or diverted away from the normal. This is the first case when density of the first media is more than density of the second media. Now what is the second point? When D1 is a less than D2, means when the light rays has to travel from the media with the lesser density to the media with the higher density. Now what will happen in this case? So when it has to be travel, so in that case, now if this is the surface and that is a normal over here, now the light is incident over here. So when this media has a higher density, light has to travel from lower density to the higher density. it will bend towards the normal. So the light will bend towards the normal. So that means what are the important factor means when the light has to travel to the denser media, there will occur. So due to that, the angle of reflection that will be very small. The angle of refraction that will be very small. So it will bend towards the normal. While when the density of the light, so when the density is more than the D1 incident area, medium has a higher density, then it will bend away from the normal. And when the incident area has a lower density than the second media, so in that case it will bend towards the normal. So this is the how density will affect through the propagation of the two waves. Now, so that means first is a reflection is a, so refraction is a bending of light or waves when it passes from one medium to the another media, and that bending of the light that will occur towards the normal or away from the normal depending upon the medium's density for the propagation. Whether the light is propagating from one media to another media with a higher density or with the lower density. So this bending of the light is caused due to differences in the density between the two substances. Means due to difference in density of the two substances, there occur bending of light. And second, when both the media have the same density, then it will follow the same path. No bending is taken place. That means the light, it will not get bent towards the normal or not get bent away from the normal. So it will follow the same path. So refraction, what is refraction? That is a change in direction of the wave passing from one media to the another media. So that is a change in direction from passing of the wave when it is passed from one media to the another media with difference in the density. When the density is different, it will either bend towards the normal or it will bend away from the normal. So refraction of light is a one of the mostly, now what is a refraction? So basically in case of sound waves, so that will happen. So this phenomena that is observed in case of sound waves and the water waves. Means in day-to-day life, when there occur the sound waves and the water waves, we are suffering the phenomena of refraction. So refraction makes it possible for us to have optical instruments such as magnifying glasses, lenses and prisms. Now, what is the uses of this refraction? We know that when the light is passing on the prisms or the lenses, we are able to see the magnifying images of the object. So that's why refraction is used over there. And second, it is also because of refraction of light, we will be able to focus the light on our retina. Now, what does it mean? That means when if there is a prism over here, now we want to see this object over here. We know that we want to illuminate this object, then we can see this object. When the light is incident on this object, now again at this point, what will happen? Some portion is get reflected and some portion is get refracted. Again at this point, the light will be get reflected and the refraction will be there. So we will be able to see the object from this place. So that means when the point objects are seen through the prism, magnifying images of the objects that will be seen. Also some lenses are used in order to see the magnifying images. So how the magnifying images is used in the day-to-day life, in order to see the objects, the light will fall on retina of our eye and we can see the magnifying images of the objects. So refraction, it has important application in our day-to-day life where we can see the object when the light is falling on the prisms and also on the lens. So that's why we can be able to see the refraction. So and also refraction occur in case of water waves and the sound waves. Means how their compression and the rarefaction of the waves, they will be get superimposed on each other in order to travel the waves from one place to the another wave. So there we can be able to see the objects over there. That means in optical instruments, in order to see the magnifying images of the object. So that's why some portion of the light that is get reflected and some portion of light that is get refracted, and we are able to see the magnifying images of the objects over there. So these are the laws of refraction. Now what is the cause of refraction? So that is important over here. Now, why there occur? Refraction will be occur there. The cause of refraction, that is a change of speed which result in the change of direction. Because we know that when the light travels from one media to another media with a different density, the speed of the particles that will be changed. So, due to change in speed of the particle, there will be the cause of the refraction. So, change in what is the reason for the change in or the causes of refraction? The change in speed that results in the change in its direction, means the light is either moves towards the normal or either it moves away from the normal. So, due to that motion or due to change in speed, that will change in its direction and that will cause the refraction. So, that means we know that the light ray refracts when it travels at an angle into the medium of different refractive index. So, one case what is required? Different medium of refractive index. Now, we are taking here two media. One media is air over here and second media is glass. We know that the refractive index of air that is a 1, while the refractive index of glass that is 1.66 something, or depend upon the properties of the glass. So, we can take the refractive index of the glass over here. So, now both are having a different refractive index. What does it mean? That means in both cases, the particles distribution that is different. More the refractive index, that means more denser will be the distribution of the particle in the media, and the difference will be the speed of the particle. We know that depending upon the refractive index, so refractive index that is equals to n by that is the number of particles divided by in the media divided by velocity v. So, depending upon that, the refractive index that can be defined over here. So, the light ray refracts when it travels at an angle into the media at different refractive indices. This change in speed result in the change in direction, because here when the particles are lesser over here, the light rays that must have the different speed over here, and when it has to travel from one media to the another media, its speed that will be changed, because now here the density of the particle is small, here the density of the particle that is very large, and due to large density of the particle and there occur multiple refraction and the angle of the rays that will be changed. Automatically there the direction of an speed of the light wave that will be changed. So, that means this change in speed result in change in direction. As an example, consider air traveling into water. The speed of light decreases at its continuous travel at the different angle. That means we know that when the light is get incident from air to the water, means when the light rays are traveling from air surface, let us see that it is traveling into the sea water or to the any glass surface. Now, again, due to change in density of the material, the multiple reflections which are taken place due to number of particles present over here, the light get refracted at the different angles automatically. If now this is a more dense media, that means the light bends towards the normal. Now, if we are taking the opposite situation, so in that case, it will bend away from the normal. So, that is the main cause of the refraction over here. So, refraction, that is possible results due to change in speed, due to change in direction of the light waves. So, now let us take a short break. Till now we understood what is the laws of refraction, how the light when changes its path or changes its speed and direction when it travels from one media to the another media.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Now, before break, we understood what is why there is a cause of refraction. So, how when the light propagates from one media to another media, that is get reflected and also refracted. So, what are the laws behind that? Now, mathematically, we will understand what is the laws of refraction and how that is responsible for the refraction of the light when it travels from one media to the another media. So the laws of reflections are refraction of the light. These are defined as, so basically first, why there is a reason of refraction of the light. So the light is get refracted. We know that when there is a light, so if there is a normal, so first requirement is that medium must be different. That must be different media must be present. Means light has to travel from one media to another media with different density. If this is so, in that case, the light is get refracted. Means now, if now density of this media D1 and density of this media is D2, so depending upon that, the light get reflected, incident and refracted. Now, if this is angle of incidence, now we know that if this D2 is more than D1, then what will happen? The light will bend towards the normal. Now, why this is so? Why light bends towards the normal? That means if this is a lesser dense media, particles are separated from each other with a large distance. Means they are get separated from each other. So here the distance between particle is large. If the distance between particle is large, density is small, then what will be the speed of incident light? That will be different. While in this case, the distance between particle is small. That means particles are closely packed to each other. So if the particles are closely packed to each other, so automatically there must be different speed of the particle. So if the speed is different, so automatically the angle of incidence and reflection and the refraction, they will be get changed. So change in speed of the light when it travels from one media to another media, that is a reason for the refraction. That means here the light travel from air to glass. So in this case, when this is a case, so here the bending of the light will take place towards the normal. But when we are taking the opposite case, so in that case, means when light has to travel from glass to air. So in that case, if the glass is there, means this density is D1 and air is here, and the light has to come from D1 more than D2, then what will happen? So the light is incident over here. Now that means the particles are closely packed in this media. Here the particles are not closely packed. So they are having more distance between them as comparison to this case. So in this case, what will happen? The light will bend away from the normal. So this is angle of reflection over here. So angle of refraction, that will be more in this case, because the speed of the light wave, that will be different. So if the speed is different, so automatically it will bend away from the normal. So this is a case, that is a reason for the refraction. So change in speed of the light when it travels from one media to another media, that is a cause of refraction. Now what is the laws of refraction, which states that the incident ray, refracted ray and the normal to the interface of two media at the point of incidence all lies in the same plane. Now what does it mean? So that means incident ray, normal and this reflected ray and the combination of these two media, all these things that must lies in a one plane. The incident ray, refracted ray, normal and the two different medias, all they must lies in a one plane. So this is the first condition over here. Then the ratio of sine of the angle of incidence to the sine of angle of refraction, that will remain always constant. So what does it mean? Means sine of I, if this is angle of incidence, sine of R, if this is angle of refraction, this distance, this ratio, that will always remain constant. So this is a Snell's law of refraction. What is a Snell's law of reflection? That is a theta I must be equals to theta R. That means angle of incidence, that must be equal to angle of reflection. While in case of refraction, what is there? The ratio of sin I upon sin R, that must be constant. So this is the law of refraction of the light. So next, the reflection of light in real life. What will happen? While the mirage and the looming are the optical illusions resulting from refraction of light, we know that in some, what is a mirage effect? Mirage effects that occurs in the day-to-day life, that is due to the refraction of the light. While the swimming pools always look shallower than the rarely, because that is because of, again, because the light is get refracted from the bottom surface of the pool. So that's why due to refraction of the light, their size is seen bigger than the actual size. Then again is a formation of rainbow. That is also example of refraction of the light from the sun rays, because as the sun rays falls on the raindrops, so there occur refraction of the light. So light will get due to continuous refraction of the light in the rainbows, the light is get trapped in the rainbow. So that's why different colors are get originating. So that is the main reason why we are seeing the formation of rainbows. That means all the different colors on the sky when the sun lights or the sun rays get shines on them. Or also when the white light that is passing into the prism, that is get splitted into the different component. So there we will get the red, orange, yellow, green, and different colors are there. Now why this is so? So that means when the white light, here there is a white light. When the white light is incident over here, so due to different angle of reflection over here, the different colors are appear in the resultant light. That means the white light, it is a combination of different colors, blue, green, red, violet, and etc. When the white light is incident on here, all the angles, they will get separated out. Now why this is so? Because the different colors travel through the prism, that is a different media with a different speed. So due to different speeds of the color, the light is get separated into the different colors when the white light is incident on the mirror on the prism. So means in the prism, because the medium of this prism is different. Now if refractive index is mu1, if this is mu2, mu1 that is not equals to mu2. So difference in the refractive index of the both of the medium where the light is get incident and on the another media. Due to this, the speed of the light, that will be different. Speed of the light or the speed of the colors by which the light is get formed. So due to speed of the light or the colors by which white light is get formed, they have the different speeds. So due to different speeds, one color will travel faster and the one color will travel slower. So due to different speeds, the white light is get splitted into the different colors when it is passing from the prism. So this is the main cause of refraction, that is due to refraction. So these are the main principles by which the light is get reflected. Now what is the mirage angle over here? Mirage effects. So mirage effects, which is depends upon the phenomena of refraction also. So according to which that is also known as the optical illusion. So in mirage effects, when there is a sunlight is shining on some surface, it is seen that some water droplets are present over there, because when the light is incident on some surfaces, the whole of the light that is get whole of the light that is get reflected, means no refraction phenomena is present over there. So the gathering of the light at one place, that will took place. Due to gathering of the light at one place, that is the cause of mirage effects. So that's why there is a mirage effects is present. Now next is the formation of we know that the rainbow is also, that is due to presence of the light which is present in the raindrops. That's why we are seeing the rainbow over there. Now next is the now what is the total internal reflection? How we can calculate this total internal reflection and what is the phenomena behind this? Total internal reflection is basically what will happen here in this case. That means when the light is incident on some media and it is totally get reflected back. No light is transmitted or the refracted. So what is this? So this will happen when the angle of incidence I and this is the angle of reflection R. So in that case, if this is a theta I angle and this is a theta r, so theta I, that angle is known as here the Brevister's angle. So that angle is known as the Brevister's angle. Means at this angle there will occur the total internal reflection of the light. And also it is seen that at this angle a whole of the light that is get reflected. No light is get transmitted from one surface. That means when the one it is get different separated, though two medias are get separated over here, neither of the light get refracted over here. So this is the mirage effects is based upon the total internal reflection. So due to the total internal reflection of the light, that means the light is get totally internal reflection, and it is get light in this case that is get surrounded, or that means collected at the one point. So that's why we are seeing the objects at that place which are not actually present. So means when we are seeing the street portion from very far away, it is seen that some water is present over there. So in the deserts, that is also seen that there occur the presence of some water is there. But that is truly that is not so, because this is depends upon the total internal reflection. Whole portion of the light, when it is get reflected back, it is concentrated at the same point, and due to that no portion of the light that is get reflected back, and as there is no reflection back of the light, so we are seeing this light concentrated at the same point. This effect of the light, that is called the mirage effect. So now these are the laws of refraction. How the light is get refracted from the surface, how we can see the rainbows, colors, different colors of the light, and the white light is get splitted from the prism into the different colors. So that is depends upon the laws of refraction, which is given by the Snell's law. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.